5G networks are being introduced today rapidly at scale. The benefit of 5G is largely coming from dramatic improvements in performance. But with those performance comes with deployment challenges, operational challenges, equipment challenges. In order to meet the needs of this sort of emerging set of use cases, which are both industrial as well as consumer based, we need to actually do a number of things. 5G brings with it new bands, new frequencies, which allow for a much higher capacity, albeit at a limited range in some cases. To be able to achieve even some reasonable wide area coverage, massive MIMO technologies and beamforming in general have been added, in addition to densifying the network massively to be able to increase at scale the capacity and performance of the network and provide a reasonable overlay to 4G LTE technology. Beamforming technology and those wider bandwidths actually translate into dramatically increased compute requirements for RAN. That ultimately could translate into increased capital expense, increased operational expense, as well as operational complexity, additional real estate costs. And then, of course, many of these sites, being in remote locations, have lots of constraints, physical constraints, power supply, and power constraints. But in general, what we know about 5G is that it's driving us towards wanting to achieve a higher capacity, leading to ultimately a large increase in the number of physical sites. VMware is uniquely positioned to provide Open RAN technology at scale for 5G by providing a compact horizontal platform with full-scale automation that can be rapidly deployed. We are doing this today with DISH that will essentially allow them to have real-time workloads fully virtualized at physical cell sites and local data centers. Under the hood of the VMware solution is optimized kernels for real-time OS and a Kubernetes management system and cluster, as well as virtual machines that isolate, secure, and protect the hardware and provide the environment that operators would like to be able to scale with. So why is RAN moving to cloud? What is the motivation really finally to go from traditional bespoke kinds of solutions into something that is cloud-based? We mentioned that two of the primary use cases specifically for RAN are either consumer or industrial based. In the consumer case, as well as in the industrial case, we're starting to look at a model with many operators where RAN would be deployed as a service. Because of the extraordinary capacity demands and needs, and because they're flexible and the demands may vary, we need to be able to move around flexibly workloads and do traffic management and traffic steering according to what's available, both in terms of coverage, capacity, and compute. All of this drives us into a new space with respect to software automation. Software automation gives us essentially an opportunity to now introduce new paradigms for doing management and control of the network, linking what has been present on the transport network and core network for a while to the RAN, essentially defining a software-defined RAN, a software-defined network, end-to-end, using cloud-native and continuous integration and continuous delivery or CI/CD DevOps type automation paradigms that allow for continuous innovation to take place in the network. All of this is enabled largely through the power of cloud. The power of cloud is, of course, dependent strongly on the movement towards generalized COTS hardware versus specialized hardware. Sometimes we may introduce smart NICs, NIC function that will accelerate and improve performance and reduce TCO. There are a number of vendors today that are actually offering solutions that will emerge in the next year or so that essentially offer this. Underneath that, of course, is that we have open APIs for multi-vendor best-of-breed implementation for the RAN. So no longer is the operator stuck on a particular RAN solution. They can easily move from one RAN solution to another, depending upon the usage and the use case. This ultimately leads to better CapEx for them and ultimately an innovation cycle that ultimately improves them with respect to operational improvements as well. So the journey in the path to cloud is not simple. First, RAN is new to cloud. And of course, cloud is new to RAN. Cloud infrastructure has to be evolved specifically to support these real-time workloads. RAN is deployed in a sort of multi-site distributed architecture. This leads to us now having to run real-time workloads in a multi-cloud architecture, a combination of cell sites and local data centers, and even centralized edge data centers. This capability comes with it a need for us to drive towards a platform which is highly distributed, but also scalable. Workloads need to be able to work together as well as independently. They also need to be secure. We finally have to have the capability to support workloads from a variety of vendors and a variety of hardware platforms, as well as network functions that come through a variety of variety of providers. So what this is doing to us right now is creating some challenges with respect to how fast we can go. And there are a number of resistances that we face today with respect to status quo forces that perhaps want to do things the traditional way, but then not necessarily gain the advantage and the scale that they could have with cloudified RAN. So solving this traditional RAN challenge is not simple. We can imagine that today with a pre-integrated SAC, what we know is that it's largely deployed at scale. It's deployed once. It's somewhat inefficient, somewhat inflexible for adding capacity and moving capacity and compute around the network as it's needed. What results from that is we often end up with underutilized systems and significant resources being maintained at scale that aren't actually being used for connections or for improving user experience. On top of that, because of the significant investment in the ground, we often are forced to deal with systems that have essentially very long life cycles. As we move to a virtualized and open RAN, what we see, of course, is that the open ecosystem allows us to move to essentially RAN with choice. It allows us to segregate hardware from infrastructure, from application, from overlay software, essentially creating these 4 layers of software and hardware that now can be managed somewhat independently, which ultimately drives to more choices, but also to flexibility in how the network gets deployed. And if inefficiency changes to something that becomes more efficient by effectively reducing the total OpEx as the scale and the complexity of the network grows beyond what humans can normally do with traditional NOCs and traditional crews and field force teams, we need to have a scale network that can ultimately be deployed with the maximum amount of optimization through centralized system management, essentially leveraging all the cloud native principles that we've applied for other large scale networks that have been deployed for enterprise. And finally, with virtualized and open RAN, we have the opportunity to, again, introduce innovation on a very rapid cycle, free ourselves from a tie to equipment. We can replace the equipment without necessarily changing the software. And finally, make operations as well as performance elastic to meet the needs of dynamic customers, giving us the highest amount of flexibility.